All right, so we're going to go ahead and learn how to solve a system of linear equation by graphing. You all know how to graph lines, but now what we're going to do though is we're going to extend that and we're going to solve a system of linear equations. And so a system of linear equations is where you have two or more linear equations and you're trying to solve that system. So it'll look something like this. So let's look at number one. It'll look like y equals 2x minus 3. So remember, we're dealing with linear equations, so all these are lines. And the other one is y equals negative 3x plus 2. All right, so we have this system. We have two more equations that we're looking at, and we want to find the solution to this system. Now, sometimes, though, you may see it written like this. You may see it written with a brace. So you have a brace and you have those two equations, y equals 2x minus 3, and then y equals negative 3x plus 2. So just keep in mind, you may or may not see a brace, but it's still considered a system. And what you want to do is solve this system. All right, so before we look at how to solve this system, and we want to solve it by graphing, and there are other ways to solve a system which we're going to learn. So another way is to use substitution, and then another way is to use the addition-elimination method. Most students will use those other two than graphing, because graphing, you have to be very careful. You have to be precise, but you still have to know how to solve a system by graphing. And so in our lesson, we're only looking at two equations. So we're looking at two equations. So when I graph a line, there are several things that could occur. When I graph a line, I could have the two lines doing something like this, right? So where the two lines intersect, and they intersect at this one point. So this, we'll just call this for right now the point of intersection. All right. Then another thing that could happen is that I could have two lines that do not intersect. So they don't intersect. Now, these two lines that don't intersect, I want you to notice that these are called parallel lines, right? So parallel lines. So notice parallel lines have the same slope. Now, we're going to define parallel lines also for this section that we're looking at. We're going to define parallel lines as two lines that have the same slope. But I want you to notice as well that those y-intercepts, the points on the y-axis, so those y-intercepts, the place where the graph crosses the y-axis, are different. So they have different y-intercepts. All right, and I want you to also notice that these two lines do not intersect. So they do not intersect. So the one we had here, they intersected at one point. So notice they have different slopes, right? Different slopes. These have the same slope, so they do not intersect. And in the other situation is this, where you could actually have those two lines where they overlap, where one is coincided with the other. So they coincide, they overlap. And I want you to notice that those two lines that have overlapped here, they have an infinite number of points of intersection. So they intersect everywhere where you see those two lines overlapping. So these two lines, they have an infinite number of points of intersection. All right, and it turns out, by the way, that when we solve a system by graphing, so the solution, so we're trying to find the solution here. So the solution is going to be an ordered pair because you see an x and a y. So it's going to be an ordered pair, and you're trying to find the point where the point that satisfies both of those equations at the same time. So whatever x and y is, when you substitute it back into both equations, the left side will equal the right side. The left side will equal the right side. Okay? It turns out that when you graph, that point of intersection is the solution. That's the point they have in common. So that will be your solution. The point of intersection is going to be the solution. So notice that when you have different slopes, there's only one solution. When you have parallel lines, you have no solution because they don't intersect. When you have two lines that overlap, you have an infinite number of solutions. And the solutions will be those points that are on this line right here. No other points. See, there's an infinite number of points in the plane, but your solutions are only those that lie here on this line. All right, so that's what we're dealing with. All right, so let's go ahead then and talk about how we're going to solve this system. Okay, so there are multiple ways to graph a line. You've learned about this in previous lessons or in previous courses. So to graph a line, you could use a t-table, you could plot points, you could use slope-intercept, things like that, right? And for this lesson, and by the way, when we're dealing with this lesson here, our lesson will be focused only on this type. So you're going to have the two lines with different slopes, and so you're going to have one solution. Okay, so let's go ahead and look at that first equation. So we're going to graph each of those lines separately. So let's look at the first one, y equals 2x minus 3. Now the way I would do that one, now again, you could use a t-table or you could use slope-intercept. I want to use slope-intercept here. So remember, whenever you get y by itself, that's slope-intercept form. Slope-intercept form. And remember, that's y equals mx plus b. And the coefficient of x, this m here, that's your slope. And then b is your y-intercept. That's the point of the graph where the point where the graph crosses the y-axis. So in our case here, y is by itself, so it's in slope-intercept form, so the slope here is 2, the coefficient of x. Don't say 2x, the slope is just 2. And my y-intercept is this constant, which is a negative 3. And just to let you know, there are multiple ways of writing this 2 right here, right? So you could say 2 over 1, or you could say 4 over 2, 6 over 3, and so on. So there's an infinite number of ways. You could even say, if you want to, negative 2 over negative 1, which is also the same as negative 4 over negative 2, and so on. So all these rational numbers that you see here, which is an infinite number of them, are all equivalent. They're all equal to 2. And it would not matter which one you use to graph. All right, so let's do that. Okay, so to graph a line, I need 2 points, at least 2 points. And I already know one of the points in that line is that y-intercept. So let's graph that, let's plot the y-intercept. So the y-intercept's negative 3, so that's where the graph crosses the y-axis. So here's negative 3. Now be careful, because when you do this by graphing, you want to make sure that you put the point where it should be. So see what I did? It's kind of like a little off. So just be careful when you do that. Be very careful. Because if the lines aren't exactly where it should be, then your intersection will be a little off. All right, so just be careful. And when you're solving a system by graphing, you want to use points that are integers. You want to use ordered pairs that are integers. No decimals, because then you're approximating even more. All right, so you'll get integers wherever those grid lines intersect. See where this grid line intersects with this? That is 4, 6. All right, so those are integers. All right, now remember, I need at least 2 points. So I know one of them, that's a y-intercept, and I'm going to use the slope to find the other point. Now remember, slope is rise over run. Okay, rise over run. So rise meaning go up and down, run meaning left and right. So from this point, always go from the point that you know is on that line. So the point I know on that line is this y-intercept. From that point, I'm going to use rise over run. It does not matter which of these you use. Almost all students will use what they see here. So they see 2, so they're going to say 2 over 1 is what they're going to use. It does not matter. All right, so let's do that. So rise is 2 divided by, rise over run is 2 divided by 1. So rise, since my rise is positive 2, I'm going to go up 2 from this point, from the y-intercept. So 1, 2, and then my run's a positive 1. I'm going to go to the right one. So that's where I'm at. Now, what some students will do, just to make sure they're drawing this line as best they can, is they'll do one more point. So just do another point on that line. So from here, go up, use rise over run again. So up 2, to the right 1. And then use your ruler to better approximate where that line is supposed to be. So when I do that, I get this. So that's the line right here. That's the line y equals 2x minus 3. Okay? And when you're and some students will label the points. You don't have to. For example, this point right here is 2 comma 1, and so on. So you don't have to label these, but there are situations where you will be told to label the points. So that's what I mean by labeling the points. What are the coordinates? All right, let's look at the next line. The next one is y equals negative 3x plus 2. All right, so we're going to do the same thing. So it's in slope-intercept form. So right away I know my slope is negative 3, which I'm going to write as negative 3 over 1. And my y-intercept is a positive 2. So I'm going to graph that line using slope-intercept. So my y-intercept's 2, so positive 2. So right here on the y-axis, so that's a point where the graph's going to cross the y-axis. And before we go on, just remind ourselves, see the slope was 2, right? So since the slope is 2, your line better rise. And over here, my slope is negative 3, so the slope is negative, so that means my line falls. So it should be doing something like this. All right, so just keep that in mind. All right, now from this y-intercept, from the point that we know is on that second line, I'm going to use slope. So rise over run. So rise over run is negative 3 divided by 1. And it does not matter whether you say 3 divided by negative 1 or negative 3 divided by negative 1. It does not matter. You could, even if you want to, say negative 9 divided by 3. It does not matter. Most students will use what they see. Almost all students will use what they see. All right, so from this point, now from the point here, you're going to, since my rise is negative, you're going to go down 3. So 1, 2, 3. And then my run's a positive 1. I'm going to go to the right one. So right here. And then, and let's do one more point, just to make sure I draw this just as best I can. From this point now, I'm going to do rise again. Rise over run. 1, 2, 3, to the right 1. And then, let's see what we get. So when I do that, I am going to get this line right here. And this is a line y equals negative 3x plus 2. And notice that those two lines intersect at this point right here. So the intersection, which is 1, negative 1, that's the point 1, negative 1. And that is your solution. So that's the solution. So the solution is a point of intersection. So the solution here is going to be 1, negative 1. That's your solution. Now, you can always check very easily by inspection. So basically, this is your x, this is your y, right? So go back to the original problem and check to see if this point satisfies the equations. So y is negative 1, x is 1. So let's check. So y is negative 1, right? X is positive 1. So 2 times 1 is 2. 2 minus 3 is a negative 1. And that's what we wanted. Over here, y is negative 1. X is 1. 3 times 1 is negative 3. Negative 3 plus 2 is a negative 1. So what we have is correct. All right, let's look at number 2. So that is solving a system by graphing. All right, and you have to be very careful with your graphs. If it's off, see, if I had drawn a little off, it may be a little off here, and you would think that the solution would involve a decimal in this case. And anyway, it does not, because your solutions are integers. For us, though, just to let you know, our solutions will be integers. They don't have to be, because your lines, and I showed you this earlier, if I can find it, you could have your lines intersect where they're not integers. See right here? Those would not be integers. Just keep that in mind. Okay, number 2. So here's number 2. Number 2, we have y equals negative 5/3 x plus 1. and the other one is y equals negative 1/3 x minus 3. All right, so let's graph the first one. So here, my slope, remember this is slope-intercept form because y is by itself. My slope is a coefficient of x, so my slope is a negative 5/3. My y-intercept is this constant, so that's a positive 1. For this one, my slope is a negative 1/3 because it's in slope-intercept form. And my y-intercept is this constant, which is a negative 3. Okay, now let's graph this. So then we're going to graph those two lines. So let's do the first one. So to graph a line, remember to graph a line, you need 2 points. So the y-intercept's one of them. So here's 1. So there's y-intercept 1. And then from that point, I'm going to use slope. Slope, which is y over run. So my rise is a negative 5, right? And my run's a positive 3. So from that point, I'm going to go down 5. 1, 2, 3, 4, 5. And then I'm going to go to the right 3 because my run's positive. 1, 2, 3, right here. All right, now let's do one more. So negative 5/3 again. So 1, 2, 3, 4, 5. 1, 2, 3. So that way I can draw this graph as best I can. So then we're going to get something that looks like this. Okay. All right. So that is the line. I'm going to put that here. That is the line y equals negative 5/3 x plus 1. All right, let's do the other line. So the other line has this information. This time the y-intercept's a negative 3. So here's negative 3 right here. And then from this point, I'm going to go down negative 1, up to the right 3. Now, just to let you know, you could have said 1 divided by negative 3, right? In that case, you would have gone up negative 1 to the left 3. Does not matter. Does not matter. All right, so let's do this one this time. So we're going to go up 1 to the left 3. 1, 2, 3. Like this. Let's do it again. Up 1 to the left 3. So here's my other point. Okay, and so I'm connect those 3 points and draw my line. And it looks something like this. So just do the best you can. We are graphing them, so you should, I messed up there, but you should be very accurate with these. All right, and notice those two lines intersect. First of all, you knew they're going to intersect, right? Because you had different different slopes. And the point of intersection is your solution. So there's your solution right here. And so the question is, what is that point? Well, that point is 3, negative 4. There's your point, 3, negative 4. All right, so the solution here, is going to be 3, negative 4. All right, and let's just check this real quick, just so you see what it looks like. So let's just check it. Now I'm going to do this one without mentally talking about it because there are fractions here. So let's do that. Let's check. So let's remember what we're saying is that this point is a solution to the system, meaning that when I substitute 3 for x and negative 4 for y, it satisfies both of these at the same time. That's what that means. So my first equation is this. And in place of x, I'm going to substitute 3. And in place of y, I'm going to substitute negative 4. So I have negative 4, and I want to see if that's going to equal negative 5/3 times 3 plus 1. The 3's divide out. This right here becomes negative 5 plus 1, which is a negative 4. And that's what you wanted. But you got to check the other one. So the other one is y equals negative 1/3 x minus 3. So y is negative 4. I want to see if that's going to equal negative 1/3 times 3 minus 3. The 3's divide out. A 1 and a negative 3 is a negative 4. All right, so there's your solution. Now, you don't have to check, by the way, but if you want to, you can. And you could have probably done that mentally without having to write things down. All right, now let's look at number 3. Okay, now number 3, we have this. Okay, so here is number 3. All right, we have this system, and I'm going to go ahead and use a brace this time because sometimes we use braces, sometimes we don't. So we have y equals negative x plus 1. And the other equation is x equal 3. Okay, so let's talk about that one. All right, so my first equation, when I look at it, y equals negative x plus 1, it's in slope-intercept form. So since it's slope-intercept form, I can determine the slope and the y-intercept. So my slope is a coefficient of x. So notice that I can also rewrite this as y equals negative 1x plus 1, right? And so the slope then is negative 1. And my y-intercept is a positive 1. All right, so let's go ahead and graph that line. So my slope's a negative 1, my y-intercept's a negative 1. Since my slope is negative, I know that my line has to fall. And I'm going to write this as a fraction, negative 1 divided by 1. So rise over run. All right, so here is my y-intercept right here. And I'm going to use the slope to find another point. So negative 1 divided by 1. So I'm going to go down 1 to the right one. Let's do another one. Down 1 to the right one, and so on. All right. So always try and use 3 points. That way you know that when you draw your line has to go through those 3 points. And it'll look, it'll give you a more accurate drawing. All right, so I have this. Okay, now let's talk about this one, x equal 3. X equal 3. So let's talk about that. Notice that this is not slope-intercept form. Slope-intercept form is when you get y by itself. All right, and whenever it's in slope-intercept form, you have a slope. There is a slope. Notice that there's no y here. There is no y. Okay, so let's kind of remind ourselves about, well, what is that? What is x equal 3? If there's no y and this is not slope-intercept form, what is the slope? Because we've been talking about slope that whole time, but now you're saying there's no slope here. Well, let's think about that. So x equal 3, if I look at this in terms of a t-table, x equal 3 means that x is always equal to 3. That's what that means. X is always equal to 3. No matter what y is. So y is 0, x is 3. If y is 2, x is 3. If y is negative 4, x is 3. If y is 2.7, x is 3. That's what that means. This is not slope-intercept form because there's no y. And it turns out, by the way, let me just kind of do it on here. So we're going to graph this line here, and so I get the point 3, 0, which is here. I get the point 3, 2, which is here. I didn't mean, this is not 3, 0. 3, 0 is right here. Excuse me. Apologize. This is 3, 3, 3 right here. So 3, 0, 3, 2, 3, 3, 3, negative 4, and so on. But it doesn't matter because you know it's going to be a vertical line. So x equal a number, if you can remember this, x equal a number is a vertical line. Vertical line. And when I draw that vertical line, I get this. I get this right here. So this is x equal 3. Okay? Now, it turns out that vertical lines have no slope. So that's why, so when see there's no y here. So if you have a line in a linear equation and there's no y, then you're going to have no slope. So you can't talk about graphing a line using slope and intercept because there is no slope. A vertical line has no slope. All right, and in this case, you'll see it also doesn't have a y-intercept, but that's okay. When you talk about slope-intercept form, you could have an intercept that that crosses the origin in this case. But notice that vertical lines, almost all of them don't have a y-intercept. Now here you got to be careful. See this right here? You could have a vertical line that is the y-axis, and there's an infinite number of y-intercepts. So you just have to think through the process. All right, now the point of intersection is the solution. I did not do a very good job drawing this line right here, because it turns out the point of intersection is going to be this point right here. And see, it didn't quite make it to that point. So just from saying, be careful whenever you're using graphing, because it could be that your tip of the point's too thick. It could be that you didn't quite align the points. But your point of intersection is this right here, and that's the point 3, negative 2. So that's your point of intersection, 3, negative 2. Okay? All right, let's look at this one. Number 4. So number 4, we have this system, y equals 4/3 x minus 3, and then y equals 1. Okay, so y equals 4/3 x minus 3, and y equal 1. And I'm just going to go ahead and use a brace. Okay, now, see this first one? Y equals 4/3 x minus 3. Y is by itself, so that's so I can think of slope-intercept form here. The slope is 4/3, that was easy, and my y-intercept is a negative 3. Okay? And so when I graph that one, just think about that, when I graph this one, here's my y-intercept at negative 3. And then my slope is a positive 4/3, so I'm going to go up 4. 1, 2, 3, 4. And to the right 3. 1, 2, 3. Up 4. 1, 2, 3, 4. To the right 3. 1, 2, 3. And then when I graph that line, again, do the best you can. When you graph that line, let's see what we get. Hopefully I'll do as best a job I can with this. All right, so there's that line. So that's the line y equals 4/3 x minus 3. Now let's talk about y equal 1. Y equal 1. Okay, let me put that here. Y equal 1. All right, well, y is by itself, right? Okay, so since y is by itself, we can talk about slope-intercept form. Notice, though, there's no x here. In the previous problem, there was no y. So x equal 3 is a vertical line. Y equal 1, there's no x. It turns out that if there's no x, then what we have here is a horizontal line. So when there's an x and a y, it's a slanted line. All right? When you have an x and a y, like we had here, you're going to get a slanted line, and which is what we saw here. And since my slope was positive, the line rose. Here, though, even though it's in slope-intercept form, I don't see an x. So you may say, well, what is the slope then? Well, the slope, if you think about this right here, y equals, I can rewrite this as y equals 0x plus 1, couldn't I? This right here is the same thing as this. 0 times x is 0, 0 plus 1 is 1, which is what you see here. So the slope is 0. There's a slope, it just happens to be 0. And my y-intercept is 1. Most students have trouble thinking with this when they want to graph it. So what some students will do is this. They'll think about y equal 1 as a t-table, just like we did with this right here. So this means that x always equals 3, no matter what y is. Over here, this means y always equals 1, no matter what x is. That's what that means. And so when I graph this, notice my y is 1, right? So when I graph this, I get 2, 1, 2, 1. I get 0, 1. I get negative 3, 1, which is here. So this y equals a number is a horizontal line. And the slope of a horizontal line is always 0. So all horizontal lines have slope 0. All right, and so when I graph this then, I notice that those two lines intersect at this point. And so that point right here is a solution, and the solution happens to have coordinates 3, 1. And so there's your solution. So the solution here is going to be 3, 1. Okay? All right, let's do one more because it is getting pretty long, this lesson. So let's do one more. And I want to do this one. Let's see. So let's do number 5. Let me make sure I'm getting the one I want to use. All right, so number 5. Okay, all the problems we've done, just to let you know, in all the problems we've done, all 4 problems, y was by itself, or there was another one where we had x. But anyway, with the point being that one of the variables was by itself. Number 5, we're gonna have 2 equations where the variables are not by themselves, where one of them is not by themselves. So let's think about how we're going to do this. So let's look at this system. X minus 4y is equal to negative 4. And the other one is 5x minus 4y is equal to 12. Okay? All right. So notice, though, in both of those, I have an x and a y. So if I want to, I can go ahead and put this in slope-intercept form. So let's go ahead and do that. Let's talk about how to put this in slope-intercept form. So we have x minus 4y equal a negative 4. And to get y by itself, I'm going to have to get negative 4y by itself first. I'm going to subtract x from both sides. So you just have to be a little bit careful as well. And when I do that, I'm going to have negative 4y equals negative x minus 4. Okay? So that's what I have. And then to get y by itself, I'm going to have to divide both sides by negative 4, just like this. And then the negative 4's divide out, so you have y equals, and I'm going to rewrite this as 2 fractions. So that way I can write it as y equals mx plus b. So remember, you want to write it as y equals mx plus b, slope-intercept form. So we have negative 1x divided by negative 4 minus 4 divided by negative 4, right? So a negative divided by negative is a positive, so keep that in mind. And so this becomes y equals negative 1/4 x. I'm sorry, positive y 1/4 x. Negative divided by negative is a positive, so 1/4 x. And then a negative 4 divided by negative 4 is a positive 1. All right, so therefore the slope is 1/4, and my y-intercept is 1. So from here, we can graph that line. So my y-intercept is 1, and I'm going to use the slope 1/4, so I'm going to go up 1 to the right 4. 1, 2, 3, 4. Up 1 to the right 4. 1, 2, 3, 4. And so that line is going to look like this. Okay, so that's the line x minus 4y equal negative 4. Now you got to be careful, just to let you know, I could have easily messed up anywhere in here, so be careful. Be careful through the process right here. Now let's get the other one. So the other one, we have 5x minus 4y equal 12. So let's go ahead and get y by itself. So I'm going to first of all isolate this term. So I need to get rid of 5x, just like this. And so when I do that, when I combine like terms, I get negative 4y equals negative 5x plus 12. And then dividing both sides by negative 4 to get y by itself, I get y equals negative 5x divided by negative 4 plus 12 divided by negative 4. And then simplifying this, I get y equals a negative divided by negative is positive, so that's 5/4 x. A positive 12 divided by negative 4 is a negative 3. So therefore my slope is 5/4, and my y-intercept is a negative 3. Okay, now let's go ahead and graph that line. So my y-intercept's -3, so here's where the graph's going to cross the y-axis. And my slope's positive, so I know it has to rise also. So both of those rows. And I'm going to go up 5 and then to the right 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then right away, see it intersects here, right? So I can stop at this point, or you could do it again. Up 5, right 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then you just draw the line. And you know where it intersected. It intersected right here. And so this right here is the point of intersection. And so that's your solution. So the solution is going to be 4, what? 4, 2? 4, 2. That's your solution. All right, so the solution is 4, 2. Now what I'm going to do is just go ahead and check this. So let's just check it. So let's just check. All right, so we're checking the solution 4, 2. Always go back to the original. So this is the original. Nothing else, because you could have messed up somewhere, right? Okay, always go back to the original. So here are my original equations. X minus 4y equal -4. And the other one was 5x minus 4y equal 12. So that ordered pair has to satisfy both of these at the same time. So here's my x, here's my y. So I get x, which is 4, minus 4 times y, which is 2. And I want to see if that's equal -4. So that's, 4 minus 8, and 4 minus 8 is a -4. So that's right. Let's check this one. X is 4, so 5 times 4 minus 4 times 2. And I want to see if that's going to equal 12. Well, 4 times 4 is 20. 4 times 2 is 8. And 20 minus 8 is 12. And so that's what I wanted. All right, so that's it. So that is solving a system. Let me go ahead and find my original sheet. So that is solving a system of equations by graphing. So that should help you. So we did about 5 problems here, and we did one where we had to write the equation in slope-intercept form. So that should help you get through almost all of these assignments dealing with solving a system by graphing.